All right, so we were looking at some examples of constructive and destructive interference. So what we're going to look at, the last part of this is just doing some pulse calculations, determining the resulting wave. So we're going to just move the waves or pulses 1 second forward in each and determine the resulting wave. So what you do is basically how I'm going to do it, I'm going to just use dotted lines here. So we're going to move, so they're going to overlap between seconds 3 and 4, so we move them forward. So now the red one is now going to be here, the red pulse. The blue pulse will be underneath. What we need to do then is to figure out what's the resulting pulse going to look like. So what you're doing is you're just adding the amplitudes together. So I'll do it in a green. So here, the red amplitude on the 3 second is at positive 3. The blue one's at negative 1. So the result will be a pulse at negative 2. Similar for the other side. So your resulting pulse, when those two pulses interact, this is what the resulting wave will look like. And it is possible to have square waves and different shaped waves. It depends on what the application is. So when those two, the red and blue, interact, the green is what the resulting is. And that's what we're looking for. I just want you to sketch up for me, what does the resulting wave look like? And then I always put the after picture in because I want to emphasize that once the two waves have passed through each other, they go back to status quo as if they'd never interacted. All right. So we got some more challenging shapes here. What happens if two semicircle pulses interact? So we're going to forward it a second here. So the red one is going to go from, instead of 1 to 3, it's going to go 2 to 4, 2 to 4. And the last one's going to be 3 to 5. So, oops, as round as I can make it. The blue one will be 3 to 5. And then it would be 2 to 4. So it's going to interact throughout all the interactions. So I need to figure out, I need to do my adding, what will the pulses look like? So at this point, it's only the red pulse. It doesn't interact with blue at all at this stage. Oops, I'm going to use a different color here. So use the green. So from 2 to 3 seconds here, this pulse right here isn't interacting whatsoever. Similarly, this blue section of the pulse doesn't interact with the red one. There's only that 3 to 4 stage where they interact with each other. So what I do then is I add it up. I know that the blue one is at 0, red's at 1, so I'm going to start here. Now I'm going to go to the opposite end and add the magnitudes. Red is 0, blue is negative 1, so 0 plus negative 1 is negative 1. So I have the starting and end point. Now I can pick some intermediate points if I want. Doesn't really matter if I go halfway. It looks like 0.75 and negative 0.75, so it's going to be at 0. So I'm not worried about you spending hours on this, but it looks like this is what the pulse will end up being. So the resulting pulse, when those two interact, I'm going to have a segment of pulse above, and I'm going to have a segment of pulse below. So there is my resulting pulse when those two round or semicircular pulses interact. Similarly, in the third stage here, this section is only influenced by blue. This is only influenced by red. I know it's going to start and end at those locations. Halfway in between looks like it's going to be 0 again. So it is a symmetrical shape. Get to the second stage, and there's my resulting pulse. Okay, so that's all we're doing. You're just adding amplitudes together as they interact with each other. One last example. I have a triangle and a square. They're only going to interact once, so that's 2 to 3. So I'll draw my red one in, and the red one's 3 to 4, so that it exits like so. The blue one will be right here, and then it exits like so. That way, red's going to be heading that way. So we need to add these values up. So I know that at the start here, the 2 seconds, red pulse has a 0 amplitude, blue has 1. So I know that it's going to start like that. On the other end, I know that the blue has a pulse of, or an amplitude of 1. So I'm looking right there. Red has an amplitude of 2, so that means it's going to end way up here at 3. So it's going to look like that. What does it look like in between? Well, I'm adding, because the blue goes across at 1, I'm adding 1 to everything, so it ends up being the triangle sitting on top of the square. So there's your resulting pulse. So you're just adding amplitudes. That's all you're doing as you go through and do this. Okay? So the homework, the handout would have been in the previous journal package that you grabbed. So you go through and try those questions. I'm definitely there to give you a hand because it is frustrating, especially for the people that aren't as spatially proficient. That's me. I need to have a mathematical process because I can't just look at it. There's going to be people that look at it and say, oh, this is what the shape is, and you'll be correct, but it's that strong spatial sense that you have. Not everyone's like that. So good to have a fallback as well. Make sure you understand the process and how to develop the resulting pulses. Good luck.